to grab your favorite drink. We'll just wait for a couple more seconds for Inocencio to remove his coffee mug, so we know he's here. Arno needed to drop off, but he will be back a bit later. So if I'm late with answering some questions in the chat, please do not, hold it against me. So, Philippe, can you just ask Inocencio, to remove his coffee mug if he's here? Or can you confirm that Inocencio is listening so we can continue? Thank you, Philippe. Okay, thank you. So welcome, Inocencio. Let us continue. So we will take some time now to discuss really simplistic approaches to backups, so you get the idea first about the need for auto changers, okay, and how was before them, and also how you can, for example, create different pool definitions, how you can share things in the pools. Sorry. So this we will discuss a bit about auto changers, why and how was before them, and also about pools and a bit about data spooling. Okay, with pools we'll have a simple use case to discuss. So it's far cry from a production environment nowadays. It is something that was a problem, I would say, 20 years or so ago. But again, it is a nice, simple example so you can understand the idea behind pools. So let us start first. Before tape libraries and auto changers were in an effect, backup strategies were quite simple because you had only one tape drive, so you could choose in between two backup strategies if you wanted to run backups on tapes. One was to use only one tape drive and only one tape until the tape fills, okay? And in this case, for example, if you run full once a month, a differential once a week, and incremental every day, you get the following advantages. Operator intervenes only when a tape is needed. So, for example, you just put in the tape and then just keep it like that and just use it. A minimum number of tapes are needed for the full restore, okay, because everything is on one tape sequentially. But here, please understand that we are talking about only one backup sequence, only one backup job, and easy to understand and implement, okay? And full backup, if you are using different machines, will be done, for example, on different nights. Disadvantages, if something happens to the site, you don't have disaster recovery. Everything is lost on that tape. Or if you had previous tapes, backups written on previous tapes are really old. After the tape fills, you must manually change that tape, so manual interventions are needed and does not scale well. If you have more and more backups, you will need to change tapes frequently. Practical details around this approach were when the tape fills, manual operations are required and can be used with disk storage in very similar manner. So you can migrate this configuration onto this configuration. What you can do instead of using only one tape with one drive, you can use daily tape rotation. So you use a different tape every day. You unload it at the end of a day and get it out of the site and load a new tape. You run a full backup every day, okay? Advantages, everything is stored on one tape, okay? Uh, and recovery is really simple. Uh, the other tapes are taken off site as soon as they are done. So at the end of a day, you take the tape off site. And if something happens to the site, you maximally lose 1 day worth of data. But disadvantage is a lot of manual operation, okay? And of course, because you have manual operations, you need to unload tapes every day. A lot of human mistakes can happen. Tapes live shorter lives because they are moved every day, taken off site. Then you, once you are done with that tape, with all the bunch of tapes, you take the first one, and then it needs to be rewound, etc., etc. And initial setup is really a lot more complicated. And if you have a lot of system, data will not fit on one tape. So you will again have to utilize more tapes per day. What you can do here is to use a different pool each day to force bacula to use a different tape. That's easier for you, but again, you need to load it, and pool overrides are defined in the schedule. So you can create 7 tapes and then have each of the tapes loaded before that day's backup starts. So for Monday, use pool called Monday. For Tuesday, use pool called Tuesday, etc., etc. Okay, and then you need to physically load and unload the tapes. Of course, if you don't do this, if you don't keep to the schedule, you will have problems. And you can utilize something called max start delay to cause a job to be canceled if you mount the wrong tape, so it doesn't wait for eternity. Okay. All in all, either one of those approaches, when you have a single drive, it's not feasible without an auto changer. If you have an auto changer, then you can utilize one tape until it fills, and then the auto changer will just use the other tape, and then that will allow you to have data stored on less number of tapes, on minimum number of tapes possible. You can use spooling to reduce interleaving. Little to no operator interventions. All you need to do as an operator is to make sure that tapes that are really full, you remove them from the tape library and insert new ones. If you have an auto changer, of course, the tape library also will have additional slots, not only one slot, so you can have more tapes in it. Disadvantage, no offsite backups apart from the tapes that you have removed after a certain period of time. And you can use different pool for each drive. You have multiple drives and create copy jobs to create offset backups. When managing few machines with an auto changer, pools are strictly not required, but they are useful to optimize storage space and helpful if you want to use more than one device simultaneously. But in order for you to get an idea how to utilize pools, what approach to use to define different pools, there is a simple use case I will share today with you. Again, this is just a teaching use case, okay? It was used in production a lot of time ago, okay? So please do not, use it as is, but just as an example, okay? So this is an actual problem that happened to Kern Siebold, the creator of Bacula, some 20 or so years ago. There was a charity organization. Arno even remembers. Oh, there is a question from Young Joe. Okay. I will continue with the problem. Let me see the question. Is it possible to create 2 backup jobs writing to a 2 different volume from a single client? Yes, it's possible. You create two backup job definitions and just tell them to utilize different pools. Okay. Or tell them to utilize different storages, but different pools is okay, also adequate. If they are utilizing different pools, they will have to write to different volumes. Okay, and you need to allow maximum concurrent jobs, set it to at least 2 on the client so they can run in parallel. And simple as that. No, there are no 2 backups daemon on the client, only 1 backup daemon, but 2 jobs will run. bacula file daemon. So the question was, so two backup daemons are running on the client? No. Bacula file daemon is a threaded application, okay? It can run multiple threads in parallel. Every job is a single thread, okay? So you have a file daemon, and if you execute more than one job, it just invokes more threads. But they're all controlled to a file, through a file daemon, single file daemon. So it is adequate to have only one file daemon installed. It can run multiple jobs in parallel. Like a storage daemon can read and write to multiple storages in parallel because it uses threads. Okay? Of course, there is a possibility for you to install multiple file daemons, but that comes with a different set of needs. For example, if you want to have end-to-end encryption using different keys from the same host, you need to have two, three, four, five file daemons with different set of keys. Okay, but that is something totally different, and those file daemons need to bind to a different TCP ports. So it is possible to run multiple file daemons per one host. It is possible also to run a single file daemon, but multiple jobs on one host at the same time. Everything is possible with bacula. Bacula is a Linux application, so multi-threading is something natural to bacula. Okay? More questions, or should I continue? Because Arne is not here. The last sentence could have exact same volume is not clear to me, Young Joe. So could have exact same volume. I do not understand what this, in this context, what does this mean? Is it, so you're asking, is it possible to have, okay, for you to understand, Young Joe, BMR is another backup, okay? It's irrelevant to bacula, is it a BMR or no. It just backs up additional data, additional metadata about the system plus the system itself. But okay, you're using BMR feature and you want to achieve what? So, if you want to create two BMR jobs running at the same time from a single client, it is possible if you are using different volumes to write to, so you're using different pools. It's possible, but I don't see a logic in it. Because once you create a BMR backup of a system, what you can do then is literally afterwards you can initiate something called a copy job and create a copy of that backup and place it onto another volume and place it on another volume again. So if it's much more, it's more suggested not to run multiple backups in parallel if you're backing up the same source, but to create one backup because of the performance, and then copy that backup multiple times. When you're copying the backup, there are special jobs called copy migration jobs that literally read from the volume and copy and write to another volume without a client. So they are just taking resources on the storage daemons, on one storage daemon or two storage daemons, depending where they are reading from and where they are writing to. But it is much better to use copy jobs than parallel backups. In general, it is possible to run parallel backup streams, but that would affect your primary infrastructure, file daemon, hosts that are running file daemons much more than it should be affected. Okay? So you run copy jobs. in that case. You create the first BMR backup. Once that backup is done, you just initiate a copy job that will create a copy of that backup onto another volume. So then you can, for a restore, use the original backup, or if something happens to the original backup, you can use the copy of a backup. No problem there. Okay? Should I continue, or are there questions? More questions? Okay, then I will continue. But, please feel free to interrupt me. So this is a simple example where we will demonstrate one of possible approaches to create pool configuration. Sorry. So, as I told you, it's an oldish example. It happened to Kern Siebold a couple of years, more than a couple of decades, I would say, before, because we are speaking about DDS3 tapes. Those are ancient, okay? So what happened? There was a charity organization, and the manager knew Kern and asked him to help him. Why? Because this organization had backups of a data, but they were using a single tape drive without an auto-changer manual, and their tape drive was pretty old, okay? It was a DDS3 tape drive, so it was really, really old, and it was too expensive for them to buy a new drive. But they were willing to back up only on disk, okay? And they wanted to keep their backups for 6 months, okay? So it was quite a simple problem. You needed to create a 6 month of backup data. There was no need to keep the data offsite, so they were perfectly content to have the data at the same site where the original is, okay? That is not so prudent, but they were okay with that. And they wanted to be able to restore old files, okay, on a daily basis for 2 weeks. What does this mean? If something changes today, you want to be able to restore it tomorrow and for the 2 next weeks, okay? So this means that you needed to record daily changes and keep those daily changes for 2 weeks. They wanted to be able to restore on a weekly basis for 1 month. That means that changes that happen once a week, okay, they wanted to be able to restore they wanted to be able to restore for a month in the past. So if someone changed something on Monday, and you created a backup on Sunday, and that someone changed something on the next Monday, weekly basis of restore said that you will be able just to restore something from the previous Monday, okay? And they wanted to be able to restore files on a monthly basis for 6 months, okay? So you should run your backups in 3 different frequencies. You should run backups once a month and keep those backups for 6 months. Then once a week changes for the whole week, okay, and keep those backups for 1 month. And then every day changes from the previous day, okay? This is something that is quite often seen with backup requirements. You have the frequency and the time that they are willing to be able to restore it. In general, those are quite common requirements. How does this get translated to a backup policy? Okay? So, objective: restore monthly backups 6 months. Those are files on a monthly basis for 6 months, weekly backups for 1 month, and daily backups for 2 weeks. Monthly backup would be a full backup, okay? And you keep 6 of those. It was about 15 gigabytes in size at that time, so you need to keep it for 6 months. You need 6 full copies, run on every month, once a month. Differential should be run once a week. It was about 2 gigabytes in size, so changes that were done during a week were about 2 gigabytes. and you needed 4 copies of those. So you needed to keep them for a month. And incrementals are 0.3 gigabytes, and that was how much data was changed by day, an average value, and you needed to keep it for 2 weeks, so you need 14 copies. So for you to be able to accommodate all of those backups, you will need to have at least 6 times 15 gigabytes plus 4 times 2 gigabytes plus 1403. That's all in all 104 gigabytes, 104.2 gigabytes. Of course, you will need to have some more room because you will not exactly remove the full backup after 6 months. It will be a bit longer. So a bit additional headroom is required. And they had at that time purchased a disk of 125 gigabytes, so they were okay with it. Okay, when you see that a disk was 125 gigabytes, you see it was a really relatively a lot of time ago. Okay, so what was the challenge? Because they didn't have a lot of headroom, we needed to ensure that volumes can be recycled early. That means that as soon as possible, as soon as the need for that backup ceases to exist, you need to prune it, and then as soon as possible, the volume is recycled. Okay, so you cannot afford to keep incremental or differentials for much longer time than required. But jobs are pruned per client, not per level. What does this mean? When you remember auto-pruning, when you remember retentions are defined in a client definition, and those are job and file retentions, and in a volume as a volume retention. But the pruning happens automatically each time you execute a job, so client controls it. But here you would like that some things are pruned differently according to the levels. Why? Because full backup need to be kept for 6 months. So you must not remove full jobs before 6 months. Differential need to be kept for a month. So you can remove differential, but not until they are 1 month old, and incrementals can be removed after 2 weeks. You need to have different pruning for different levels. Because a job is a job, a file is a file, pruning by jobs and files cannot guarantee you that only certain level will be pruned. What needs to be done is, or setting up retentions per job and per file cannot guarantee that different retentions will be there. So what you do, you set up retentions by a volume, because volume can only be recycled if they contain no valid data. So we must recycle the volume by defining retentions per level. And level, in this case, needs to be equal to a different pool. Okay? So the solution for this consideration is that you need to use pools and define limit of jobs per volume. You need to use so many pools as you have different levels, and you need to define different retention per different pool. And then you should enable pruning and pruning per pool retention. So job retention and file retention should be bigger than or equal to a volume retention. So jobs and files do not get pruned earlier. Okay? Of course, volume sizes can be arbitrary because these volumes do not have overhead, and you do not want to keep too many jobs on each volume. I told you that because you want to recycle them as soon as possible. Okay. So this is what we have. We have created at that time 3 pool definitions. 1 pool for full backups, 1 pool for incremental, and 1 pool for differential. Full pool for full backups should have its recycled enabled, should have auto pruning enabled, and should have its volume retention set to 6 months. Okay? We have decided to use maximum to contain volumes by jobs, and you set maximum volume jobs equals 1. So full pool will create 1 volume per each job executed, and the label will be full. and we set maximum volumes at 9. The question is, why 9? How many volumes we need to be out there in the system? What do you say? Anybody, just type in the answer. So what is the minimum number of volumes we need in that pool to be able to we create one volume per job, we run one job a month. We need to keep for 6 months. How many volumes we need in minimum? 6 is the bare minimum, but you will also need a volume number 7. Why? Because when you start creating the next pool, you will still not going to be removing the previous one. When you start creating a pool number 8, then you're going to recycle. But in general, yes, 6 a bare minimum. Why 9? I told you with 7 it can work. Why 9? What do you think? It's not a functional requirement at all. It will work with 7. Up to a point, it can even work with 6. 9, because we are paranoid. If something happens to bacula and one of the volumes is proclaimed as in error, I told you, volumes that are in error cannot be pruned, so they cannot be recycled. But we will need another volume, okay? So this is why 9, okay? And what we will need to change in this definition to be able to accommodate another source of backup, because this is quantified by the fact that we have only one source of backup, one client. What do we need to change here? One of two things, or we can change one or the other. What are those? One example. If I want another client, so I will need, in theory, double the quantity. So what can I say? Anybody? Yes, maximum volume jobs, I can set to 2 instead of 1. So it will not close the volume. It will not mark it used when the first job is run, but it will say, wait for a second job. What else I can do? Here, also, I can set maximum volumes instead of 9 to 18, and I'm good. Okay? One of those two is an adequate answer. Then, differential pool. If you remember, I need to run differential once a month. I have only one source. Okay? I need to keep it for a month. Sorry, once a week, I need to keep it for a month. And I am setting maximum volume jobs to 1 and label diff. And I've set maximum volumes to 9. Okay? Will this work? Why 9 volumes? How many volumes I need in minimum? I'm running once a week, and I need to store them for 40 days. 5, even 6, okay, because 6 times 7 is 42. Why 9? The reply is again the same. We want to have some overhead if something happens, okay? And in minimum, we need 5.6, so we need around 6 volumes. In additional for volume recycling, minimum 7. Like I discussed previously with you, we need 1 volume to overlap, okay? And the last pool is incremental pool. Here, I am running backups every day, okay? And I need to keep those backups available for 2 weeks, okay? So I can define different strategy, okay? So if I say that volume retention will be 20 days, okay, because I'm paranoid, and I say maximum volume jobs would be 6, not 1, because I want all the backups from 1 week to happen on 1 volume. How many volumes then I will need in minimum? I'm running every day, and I need to keep it for two weeks. Of course, I'm not running on Sunday. To be honest, Sunday is reserved for full and differential. So I'm running on all days apart from Sunday, for example, 6 times a week, and I need to keep it for 2 weeks. How many volumes I need in minimum? Mathematically, I would need how many volumes to cover 20 days, and I'm running it once a week. I need to cover at least 21 days or 3 weeks. So I will need 3 or more. Okay. So this is the approach. I create those 3 pools. I create one job. I create a schedule that says that full is run on first Sunday of the month. On every other Sunday, differential is run, and incremental on all other days. Okay. And I create a storage definition and a device definition. And I'm executing those jobs. Okay? Nothing spectacular. Here, pools represent not different business units. Here, pool represent different retention requirements because there are different retention requirements for every of the backup levels. And this is quite frequent these days. Okay? Even if I have one single device, I would still want to be able to store things differently based on the frequency of backup. So if I run incremental differentials and pools on different days, and I store them for different periods of time, I have a possibility to have much more granular restores. I can offer my users a possibility to restore everything what was changed in a day frequency only for 2 weeks. Everything that was changed on weekly frequency for 1 month, and everything that was changed inside of a month for 6 months. Only by a subtle interplay in between pool configuration and the place where you store and using different volumes for different levels. Okay? Of course, there is a problem to this approach. It's non-existent if you're using only one job and one client and only one device. But once you start using multiple clients, multiple devices, you're going to hit problems because then you will need to run multiple jobs in parallel and you will have interleaving. In this case, when you have multiple sources, you will need to redefine your pool definitions. Even what I would have done, I would have, instead of modifying these pools, I will created another group of 3 pools for another client. So backups of that client are totally independent of those backups, okay? But in any case, in order for me to be able to move and to utilize multiple group of pools or to be able to write to multiple volumes at the same time, I would need to use an auto changer. I would need to use multiple devices. So without auto changers, the best of bacula configuration would still be either sequential or you will have high interleaving blocks, even with disks. And that is, to be frank, really stupid. You have all these parallelization capabilities, and then you create only, a single file device. That is really limiting. So in this case, when you want to have multiple jobs, then also you create multiple devices and just use them for multiple jobs or use an auto changer to handle them. The second approach is much, much better. Okay? And now back to spooling. What if you need to write multiple files, multiple jobs to a single device? When do you need to do this? I told you before, only when you're writing to tapes. Because unlike disk devices, cloud devices, or DGIF devices, which are virtual, and you can have as many of them as you like, or as many of them as your file system will work with comfortably in parallel, okay? You cannot have as many of file drives as you like. Why? Sorry, tape drives. Tape drives are expensive. They're physical creations. They're really expensive. And the newer they are, more expensive they are. Okay? The bigger the tape library, the bigger number of drives, but also much bigger number of backups it needs to handle. Yes, there is no need for spooling for disk storage. Yes, because spooling stores data to disk, and then you will be writing it to disk again. If you want not to have interleaving with disk storage, please create an auto changer and say maximum concurrent jobs equals 1 per every other device. This is what we advise. Not to have one disk device and then spool. Okay? Spooling should be reserved only for tapes. Okay? And once you reserve spooling for tapes, you need to be really careful. Why? With spooling, you need to have a large chunk of fast disks. Okay? With spooling, it's not important to have those disks placed in a manner or configured in a manner to be able to store the data for a long time. Spooling data is volatile, temporary. So you are now aiming for speed, not for resilience. So when you are implementing spooling, please think of two things. One, think of SSD or NVMe disks, so think of flash. And two, think of striping, okay? So no mirroring, only RAID for striping, RAID 1, if I remember correctly, okay? So you're aiming for speed. Even without the RAID, even better if you can, if you can accommodate it. And also, when you enable spooling, you enable it only for tapes. You enable it because you don't want interleaving, okay? And also, once you have spooling area set in a spool directory directive, please make sure you don't back up that spooling area from some backlog job. That's totally crazy. Especially if you're backing up spooling area with the same job that is using it. You will never finish the job, okay? Yes, you can use SSD for spooling and backups on hard disks. A lot of people nowadays are using JBODs. You know that arrays of disks, relatively inexpensive disks, to store backups. Okay. Oh, you want to use SSD to spool for disk? That doesn't make much sense because in the end of the day, you're again have to have a spinning disk at the end of the line. So you will be literally wasting more time than gaining because you will be writing the same data twice. Okay? So, and also for you to understand nowadays tapes, yes, no spooling for disks, please. Nowadays tapes that are used today are much faster than disks, even SSD disks. They're much, much faster. So sometimes you will be annoyed because spooling will slow you down. So you need to be very careful how you set it up. So you need to have big spool size to have larger blocks, larger chunks written to tape. Okay? And also what you need to understand, sometimes you don't really care about spooling. Why? I've known a couple of users, they don't really care about fast restores, just fast backups, because they have tight backup windows and they need to back up a lot of data. So what they do, they just go out there and write to tapes directly without spooling. And that creates, and they write 8, 10, 16 parallel jobs to tapes. And that creates a lot of interleaving, but they don't care. Because once it comes to a restore, then it can take time. But they want to be able to back up everything or as much as possible during the backup window. So if you have a requirement like that, then you should consider not to spool. Mainly people would like to have a bit of faster restores, so they don't use this, but you can, okay? Also, modern tape drives exceed throughput of network. So if you need to spool and then I have a network jump to the tapes, please don't spool. Okay? If you sorry, if you need, if you have a network in between the storage daemon and the tape, tapes are much faster than the network, so you should spool, because then it will use the tape better for the throughput. And also, you need to understand, I think that Arno told you, that once you spool, multiple jobs stores the data in the spool area. You can even set the size limit for each of the jobs per job. So no job gets more than this, okay? But only one job is spooled. So if you have, for example, 10 jobs, they will all start writing to tape by filling the spool area. The first one that fills its chunk of the spool area, or the first one that hits the limit of the spool area, will start to despool. Others will wait. And as this one is despooling, other job will add new data, spool. So once this job is done, next job starts to despool. So if you have spooling enabled, only one job will be written sequentially on a tape in a large block. Okay? So you can use it like this. Also, what we have in some occasions, but this is just some occasion, people do not want to meddle with spooling because it takes a lot of time. So what they do, instead of spooling to set it up, they perform something called disk to tape backup, D to D to T. What this means? They first create a backup to disk, and then once the full backup job is done, then they create a copy job or a migration job, and they migrate it to tape. This way, when they are migrating into tape, they are making sure that this is the only job that gets written to tape. So the full job is written sequentially. Okay, there is no interleaving. On the other hand, you do not waste time with spooling and accessing the different jobs. So you just migrate job by job to tape later. So you have fast backups to disk. You have a staging area there, and those backups are held on disk for 1, 2, 3, 5 days, a week. And during that week, they are migrated off to tape and removed from the disk. That can also be done. Then you don't need spooling, but you just create migrations later. So there are different approaches out there around tapes and spooling. In majority of cases, spooling is not needed even with tapes if you're not concerned about tape tear and wear and about fast restores. If you are, spooling is a place to do, or later migrating to tape, depending on your idea what you want to achieve. If you have some disk stage area, possibly it's better to use this stage area to first create backups there and then migrate them to tape instead of using this area as a spool area. That will allow you also to have backups that are readily available for a week or two until they are migrated. And that can also sometimes speed up your restores because you have it on the disk tier for a week or two and then migrate it to the tape tier. And this is how majority of cloud providers or majority of tiered storages or tiered storage services function today. When you store data onto a tiered cloud, you first store it into the most expensive part of the cloud, and then they migrate it after a certain period of time to the less expensive. So you store it to a fast disk, and they migrate it to a slower disk or to tape. So you can do this also with Bacula automatically, okay? Migration and copy jobs are special part of Bacula. So they are jobs that can be initiated at each time, and they literally pick up the existing backups, and they just copy them or migrate them from one Bacula storage to other. The difference in between copy and migration is that a job that is copied is still considered to be original backup, so it is still used for a restore. In the migration process, a job that is migrated is then depromoted and becomes unusable, but the migrated job becomes the backup to be used for restore. So that's the difference. Migrated job gets promoted to a backup job. Okay, you can even automatically, once the migration is done, you can even automatically say to Bacula to remove all the metadata about the original job from the catalog. And in certain periods of time, the volume will be recycled, etc., etc. Depending on the configuration, you can create really fast disk to tape or really tight disk to tape schedule that will allow you to keep backups only on disk for a couple of weeks and then migrate it to tape and remove it from disk, recycle. And that is even better than spooling in some cases. But again, it depends on your idea. Let's get back to spooling just to recapitulate. So spooling is controlled from two sides. First, you need to configure the spooling parameters on a storage daemon. That means you need to set spooling directory. If you do not do so, it will use the working directory and it can jeopardize the storage daemon. So you need to set aside a big chunk of disk and say this directory is used for spooling. And then what you need to do also, you need to define a size. What will happen if you do not define maximum spool size? It will fill the disk to the brim and then kill the host. So you need to define maximum spool size. In addition, what you can do, if you're running multiple jobs in parallel, you should define also maximum job spool size. That means that this space will be split in between jobs, and each job will be allowed to take maximum this size. Okay? This is also good if you have, for example, spool directory set to 100 gigabytes and you're running 10 jobs. Okay? What you should do is you should say maximum job spool size is 100 gigabytes. But maximum spool size is 100 gigabytes, but maximum job spool size is 10 gigabytes. So each of the job will fill the spool space until it gets to 10 gigabyte limit, and then it will be offloaded to tape, despooled. Okay? If you don't set this one, the jobs will fight about the maximum spool size, and you will get uneven chunks. The jobs that are faster will fill the spool size much faster, and they will have bigger chunks. Okay? And once this is filled, the first job, the job that filled it will get despooled, then the next one, etc., etc. Okay? This will give you much evener, disposition of sizes. But again, I leave you to your experience. So once you set up the spooling parameters on the storage daemon, then you should just say spool data equals yes, either in the job or overwrite it in the schedule or in the run command. Once you do this, these parameters will start to be used on the storage daemon. If you don't do this, if you don't set this, spooling will not be used. That's the first thing. And the second thing is, if you do this, if you enable spooling in a job, attribute spooling is automatically enabled. Okay? If you do not enable spooling, attribute spooling is still enabled, but you can disable it. Okay? And once more, if you're spooling and you're backing up your storage daemon, please do not back up the spool directory. You can create indefinite loops like this. Because if you're using a job to back up spool directory and you are using that same spool directory to write that job, you're going just to fill the data and read the data, all the same data all over again. And this is totally wrong. Okay? Spool data is temporary, volatile data that you do not need to take care of. Okay? So please, please, please do not back up spooling directory. And to stress more important spooling points, first is make sure to specify maximum spool size, if not per job, at least as a whole, because it will fill up the complete of your disk partition. Attribute spooling, as I told you, is automatically enabled when data spools, and attributes will be despooled at the end of a job. Okay, so if you have attribute spooling enabled, either by default or automatically if you spool data, then your catalog will not know anything about attributes until the end of a job. Then it will get a bunch of data, and it can take for a certain period of time if there was a lot of files during a backup. This pooling, once the spool area is full, is done one job at a time. And one job, these spools, other jobs can spool. Okay? Spooling does not make sense for disk volumes, so we suggest not to use it, but we've discussed that. Okay? If you want to use spooling, please use big spool sizes, because in case you don't, you will have a lot of spooling, despooling, and an overall effect on a throughput might be even much lesser than without spooling. Okay, and as I told you, jobs that do not despool are spooling again. So you start reading from the spool area, but other jobs will take that data. Okay, so again, spooling is not mandatory. Nowadays, a lot of people even decide against it when they're using. So when are you using disk, please don't spool, okay? When you're using tapes, it's not mandatory. It can do a lot of good things for tapes, but some people choose not to use it if they're not interested in fast restores, and if they are not concerned about interleaving, but they want really fast backups. They just simply don't spool, because these tape devices nowadays are really fast. Okay, so test it with and without spooling, you will see the difference sometimes. If you are not interested, if you are interested in fast restores, but you do not like spooling, please consider migration jobs as an alternative. Instead of using large, fast disks to store spool area, you can use the same disks or even much less expensive spinning disks, but now in some mirroring rate, okay? And use those less expensive disks as a first tier of backups from disk to disk, and then later initiate migration jobs to migrate those jobs off to tape one by one. And you will have, again, backups move to tape outside of backup window, and you will have no effects of interleaving, or lesser interleaving if you are migrating to 2x2 jobs or something like that. Okay? So those are all major things in regards to pools, auto changers, and spooling. Are there any questions? If there are none, I will finish the lectures for today here. Next section is about bacula maintenance. What to do when you upgrade, how you maintain your catalog, and certain points about security. Afterwards, we will discuss about bacula on Windows, and then a fun part that I enjoy, some utility programs around bacula. Okay, those programs will be needed from your side to help you a lot, and then about debugging, and then we will close the lectures. Tomorrow, once we are done with the lectures, we are going to present you with your final exam task. And once more, please keep working on the exercises and work on the final exam. Okay, it's not mandatory for them to be finished this week. You will still have another week until next Sunday, but, keep them on your mind. Okay, time sometimes, passes quickly. Okay, so if there are no questions, I will stop my sharing. Okay, are there questions? Okay, and